Number 88, a person whose height is 6 feet is walking away from the base of a straight light along a straight path at a rate of 4 feet per second. Stop. So let's kind of mark that. So this person is 6 feet right here, and then walking at a rate of 4 feet per second. So I'm just going to say the walking is 4 feet per second. So now, if the height of the street light is 15 feet, stop it. So that's 15 feet. What is the rate at which the person's shadow is lengthening? Stop it. So I'm just going to call this the shadow S. And if you guys didn't see it, there are basically two triangles that will mainly matter for this problem. The first triangle is going to be this little big triangle right here. So that is a right triangle with a height of 15. And base, I don't know, but bear with me. I'm going to hold on to that for a bit. And then the next part is this little triangle right here, the small one. And that is actually 6. And once again, I'm going to call this S on the bottom for shadow. So if you can go back to this bigger triangle, that would be kind of S up until there, right? And then the rest, I will just call this, I don't know, X, right? So if you guys can see it, these two are actually similar triangles. Well, how do you prove it? They're both right triangles with shared angle right there. So by the postulate angle, who cares? That's geometry. The point is they are similar, and therefore you can go ahead and use your proportion. So what I'm going to call is this. Well, first of all, that base will now just be X plus S. So what I'll do is I'll set up the proportion and be like 15 over X plus S, and that better equal to 6 over S, right? That 15 to the 6, and then the X plus S to the S, right? So that's what I set up. And then we're going to go ahead and cross multiply both sides, or cross multiply. So that'll be 15S is equal to 6X plus 6S. So subtract 6S on both sides, and you get 9S is equal to 6X. Once I have that, now I'm going to take the derivative of that because we're talking about the rate here. So when you take the derivative, that'll be 9 ds over dt is equal to 6 dx over dt, right? What the question wants is the rate at which the person's shadow is lengthening, aka the ds over dt is what we're trying to look for, which means I need to know what that dx over dt is. Do you? Absolutely. That is what this moving along a straight path at a rate of 4 feet per second. That's what the dx over dt would be, right? So that'll be 9 ds over dt is equal to 6 times 4, right? So go ahead and divide by 9s on both sides. So therefore, ds over dt is equal to, cancel by the 3's. So that'll be 2 and then 3 here. So that'll be 8 over 3, which is 2.667. So that's why answer choice B would be the correct answer.